So we are going to look at how to expand expressions. And expanding expressions is really just utilizing our skills and our knowledge of how to use the distributive property. So when we say expand expressions, we really just mean use the distributive property. And so we have to remember what that means. And you can see this is a nice little rundown. What we do is when we're going to use the distributive property, we've got an expression set off in parentheses, as you see here, 3y minus 1. And then we also have a number outside of the parentheses. And what we do is as it says here, we multiply or distribute this term to both of the terms inside. And so we can write this in an intermediate step. What we're really doing is we're taking negative 7 times 3y. And so that's why it's written as that right here. And then we're going to add that with whatever we get when we take negative 7 times a negative 1. So just like we saw in our simplifying expressions video, we're going to take this subtraction sign and link it with the 1 in this case. And so we use the distributive property to expand that, and so we'd end up with negative 7 times 3 is 21, and negative 21y plus 7. That would be our expanded expression. And so we're going to look at some examples of doing that. So if we look, and this is from your textbook, if we look at question number 4 here, it says shoes and hats are on sale, and the expression 1/4 times s plus 24.80 can be used to determine the discount when you buy shoes with a retail price of s dollars and hats with a total retail price of $24.80. So we're going to write another expression that can be used to determine the discount. So we're writing an equivalent expression, and we talked about equivalent expressions in lesson 2 of topic 4. But all we're really going to do is we're going to take this expression here, 1/4 times s plus the sum of s and $24.80, because we're dealing with dollars. And we're going to expand it. So you remember that when we're expanding, what we're really doing is we're taking this term that's outside the parentheses and multiplying it by both of the terms inside. So we'll take 1/4 times s, and then we'll take 1/4 times 24.80. So I'm going to write that step out. So 1/4 times s, that's going to get added to the product of 1/4 and 24.80. Okay, and so now the last step is I'm just going to use my calculator or my knowledge to do that. And so if I pull up my handy dandy calculator here, I know that 1/4 times s, well, that doesn't change. It's actually just 1/4 s. And then I use my calculator. Well, what's 1/4, which is 0.25, times 24.8? 6.2. So that means that an equivalent expression to what was written originally would be 1/4 s plus 6.2. If I buy 5 shoes, I could evaluate this expression and plug that in here and get the same answer whether I do it like this or like it says up here. Okay, so we expand it. So let's look at another example where we're expanding an expression. So here we've got the expression x times the difference of 4 and 3.4y. So again, I'm going to take whatever is outside of the parentheses and multiply it by each term inside. So my intermediate step, and this is going to be really helpful to do at the beginning of these so we make sure we don't make silly mistakes, is I'm going to take x times 4, and that's supposed to be a multiplication dot there, and I'm going to add that to the product of whatever x times a negative 3.4y is. And so notice I took that negative and I just linked it with the 3.4y because that's where it goes. And then I'm going to just simplify these. So what's x times 4? Well, that's 4x plus what's x times negative 3.4y? Well, that's negative 3.4, and then the x and the y are being multiplied by each other, and so how I show that is I just write both of them there. So x times y gives me xy. So my expression is 4x plus a negative 3.4xy. And even more simplified, this would actually be, what do you think? Well, to simplify it even more, I'd actually go 4x minus 3.4xy. And so I went xy instead of yx because we usually go in alphabetical order from left to right, but it's not a huge deal. The main point is that I need to show that both the x and the y are still there. So here is my expanded expression. Alright, let's look at this last one here. So I'm going to do this last one, and it's the same thing. Now, there's one thing that's different about this, and there's two ways I could do it. The first step is when I look at a parentheses, like here, the numbers inside, is I should see if there are any like terms. And one thing I could do to save myself a step is I could actually combine like terms. So if we look here, the 1 and the positive 2 are like terms. So I'm actually going to go ahead and I'm going to combine those like terms first. So 1 plus 2 is 3. So I'm going to rewrite this inside here as 3 minus 2x. And that just saves me one set of multiplication that I have to do. So negative 2/10, which is negative 0.2, times 3. So pull up my calculator, and I probably don't really need to do this. This is 0.6, but and there's a negative sign there, so it's negative. And actually, I'm skipping something. I should rewrite this out. So I've got negative 2/10 times 3 plus whatever the product is of negative 2/10 times negative 2x. Okay, and so now I can use my calculator. I know that this negative 2/10 times 3 is really the same thing as negative 0.6. I could write it as a fraction as well. Negative 0.6 plus negative 2/10 times negative 2. So negative 2/10 times 2 is 0.4. And negative times a negative is a positive. So it's actually going to be positive 0.4. So 0.4, and that x is still there. So here's the simplified and expanded expression for this original expression written up here. So again, when it says expanded expression, what it really just means is to use the distributive property. And if we look back, remind ourselves up here, when we use the distributive property, what we're doing is we're multiplying each term inside a set of parentheses by the number that's written outside.